What if a tiny microcontroller could recognize sounds, detect movement, or even understand simple patterns using artificial intelligence? That's the amazing idea behind TinyML. A microcontroller is a tiny computer built into many electronic devices. It can read sensors, control outputs, and perform programmed instructions. Traditional AI often relies on powerful computers or cloud servers. A device collects data, sends it somewhere for processing, and waits for the result. Sending every piece of data to the cloud can create delays, require an internet connection, and use extra energy. For tiny devices, that can be a big problem. TinyML changes the idea by bringing machine learning directly onto tiny, low-power devices. The AI runs right where the data is collected. TinyML uses specially optimized machine learning models that are small enough to run on microcontrollers with limited memory, processing power, and energy. The hardware can be incredibly small. Instead of needing a powerful computer, TinyML can run on devices that may be smaller than the palm of your hand. With TinyML, sensors can become more intelligent. Instead of simply measuring data, they can help recognize patterns and identify what that data means. The key idea is local intelligence. The device can collect data, process it, and make a simple decision without constantly communicating with a remote server. TinyML matters because it could make everyday devices smarter, faster, more private, and more energy efficient, all while using surprisingly small amounts of computing power. The TinyML process begins with data. Sensors collect information from the real world, such as sound, movement, temperature, vibration, or light. Before the model reaches the microcontroller, it is usually trained using data on a more powerful computer. The model learns to recognize useful patterns. The model must then be optimized and compressed. The goal is to make the AI small and efficient enough to fit within the microcontroller's limited resources. Techniques such as quantization can reduce the size and complexity of machine learning models. This helps them run efficiently on hardware with limited computing resources. Once the model is running, the microcontroller can analyze new sensor data and make predictions. For example, it might recognize a clap, a voice command, or a specific movement. TinyML can be used for audio recognition. A small microphone and microcontroller might detect keywords, unusual sounds, or specific audio patterns. Motion is another powerful application. TinyML can analyze accelerometer data to recognize gestures, activities, machine vibrations, or unusual movement patterns. TinyML can even support simple vision applications. With the right hardware, a small device can analyze visual patterns without sending every image to the cloud. Because TinyML models can be designed for low-power hardware, intelligent devices can potentially operate for long periods on small batteries or even energy harvested from their surroundings. TinyML can also improve privacy. When data is processed locally, sensitive information may not need to leave the device in the first place. TinyML could make wearable devices smarter. A smartwatch or fitness tracker could analyze movement patterns locally and respond without constantly relying on a smartphone or cloud service. In smart homes, TinyML could help devices recognize sounds, detect activity, and respond intelligently without sending every sensor reading to the internet. In factories, TinyML could analyze vibration or sound from machines and detect unusual patterns early. This could help predict equipment problems before a breakdown occurs. In agriculture, TinyML could help analyze soil, temperature, or plant conditions locally, allowing smart systems to respond quickly while using very little energy. TinyML could also give small robots local intelligence. They could recognize sounds, gestures, or objects and react immediately without depending entirely on a remote computer. In vehicles and machines, TinyML could help analyze sensor data quickly, supporting functions such as anomaly detection, gesture recognition, or local environmental awareness.
But TinyML has limitations. Microcontrollers have much less memory and processing power than computers, so AI models must be carefully designed and optimized.
As microcontrollers become more powerful and machine learning models become more efficient, TinyML could bring intelligence to billions of small devices around the world. TinyML puts machine learning directly into small, low-power devices. That means sensors can become smarter, machines can react faster, and AI can move closer to the physical world. TinyML may be small in size, but its potential is enormous. By putting AI directly inside microcontrollers, create a future where almost anything can become intelligent. Thanks for learning with Ethan. If you enjoyed this lesson, don't forget to like, subscribe, and turn on notifications so you never miss another easy-to-understand engineering video.